vibrational motion. Let us consider a spring, and spring is connected with a ball. This is a ball. So this is a spring which is connected to a ball here, and the ball is stretched and then released. Stretched and then released. So the ball will go up and then come down. Again up, again go down. So the ball will be vibrating here in this case, up and down like this way. Now, these are the two positions of the ball. This position is called as mean position. This position is called as mean position. Mean position. And these two positions are on the extreme sides, so they are called as extreme positions. Extreme position. So this is also extreme. Okay, so these are mean and extreme positions. Now, here you see the ball is going above and coming down, and it is moving like this way. The spring is stretched and then released. Let us consider this is the starting point of the displacement. Displacement means movement of the particle above its mean position. The particle goes above and reaches this point, that is the maximum displacement of the particle above. So from this to this distance, this is called as amplitude. Amplitude, this is called as amplitude. This is called as amplitude. Then the particle again from here, this ball comes back to the original place. That means from here to here, the ball is again coming here, and this is again at the mean positions here. Then the ball goes in the other direction. Other direction means this. So the ball goes down, and finally the ball reaches at this spot. So when it comes here, so this is the extreme position. Again, the distance from the mean to extreme, this is what? A, amplitude. Again, when the ball reaches at this spot, it is here. Then the ball goes here forward, and it reaches the mean position again. So from here the ball goes to the mean position. And then from here it goes back to this place, so that is the extreme position here. And then from extreme again to the mean position, and this keeps on going, the ball keeps on going like this way, and this is the mean and the extreme positions. So this point is again amplitude. Now, between the distance between two consecutive points, this one and this one, is called lambda or wavelength. This is called lambda or wavelength. Similarly, these are two extreme positions. This distance is also wavelength lambda. This is also wavelength lambda, equals to wavelength, that is represented by lambda. This is the sign of lambda. So the wavelength is the distance traveled by wave in one complete oscillation. So one complete oscillation means above and then below. So this is wavelength. And these two extreme positions, their distance is also called wavelength, that is lambda. Now, the time taken by the wave, or the time taken by this object, that is to move up and down, one above and then below and then again back here, the time taken, that is called as time period. This is called as time period. The time taken by the object ball to go up and then come down, then again up, then come down, that time is called as time period. So this is the wavelength and this is the time period. Now, the number of times the ball goes up, down and then comes back. This is one time period. One time period. Goes up, down, down, again here, mean position. So this is this. So this time taken here by the ball to move up and then again back, again down, again back here. Total time is called as time period. Now the number of times it moves in 1 second like this way, the number of times it moves, the object moves above and then below, that is called as frequency. That is called as frequency. This is called as frequency. So wavelength is the distance between two consecutive mean positions, that is two consecutive, that is the distance traveled by wave in one complete oscillation. The distance traveled by wave in one complete oscillation is called as wavelength. That is the wavelength. Time period is the time taken to complete one oscillation is time period. Frequency, the number of oscillations made in 1 second is called as frequency. Now time period is represented by T and frequency is represented by N. Okay, so time period is equal to 1 upon N, or N is equal to 1 upon T, that is time period. So these are the formulas for frequency and time period, which you should know. Okay, so this is about the wave. Similarly, the amplitude is defined as the maximum displacement of the wave or the object from its mean position. The maximum displacement of the object from its mean position is called as amplitude. Frequency is measured, wavelength is measured in its unit is meter. Time period, its unit is seconds. And frequency, its unit is hertz. Hertz. Our symbol is Hz. Its symbol is Hz. Capital H, then Z. This is the symbol of it. Seconds S, symbol is S. Meter M. These are their symbols. Now, amplitude is this is amplitude. It is represented by small a and its unit is meter. Small a unit is meter. So you can say M. Meter is M. M. Now, one hertz means Hz. 1 hertz is equal to 1 upon 1 second. That means 1 hertz means 1 upon 1 second. That means if the object is moving in such a way that for one vibration it is making 1 second, then it's called as 1 hertz. Next topic is characteristics of sound.